If you had 2 pi over 3, that's the answer in radians. So you get the secant alone, and you can replace with the theta at the beginning. I just waited till I got it alone, and then reciprocal of secant is cosine. We're going to find where cosine equals 1/2. There are 2 places in the unit circle, 60 and 300. Don't forget the plus period times k, the cosine is 360. And then multiply by 2. And the only answer there between 0 and 360 is going to be 120. Do you have any questions on this one? Just a little recap from yesterday. Okay, we have a couple other problems to get through. I think there's like 5 more equations we're going to do today, and then that'll wrap up the section and chapter for us. So that's good. All right, so let's start with this one. Oop, why didn't that show up? I didn't freeze it, did I? Oh, I did. Okay. 4 sine 2x equals 1. And we're still solving in degrees between 0 and 360. Okay, so I'm going to get the sine alone first. Here I've got to divide by 4. So sine of 2x will equal 1/4. And then I'm going to go ahead and put the theta in. Sine theta equals 1/4. We'll come back to the 2x later. So now this is kind of a little bit of what we did yesterday and a little bit of what we did in section 6.5, because 1/4 is not on your unit circle. It doesn't mean it's undefined. 1/4 is between -1 and 1. So we need to use the calculator for a problem like this to be able to solve for it. Now we want answers in degrees. So double check that your calculator is in degree mode to start. Okay. All right, and how am I going to get my first answer? What do I need to do with the calculator? Inverse sine of 1/4. And I'm going to round to the nearest, let's just do to the nearest degree here. You could always do like, well, math.excel might be nearest 1/10 of a degree. Let's practice that. So to the nearest 1/10 of a degree, when you do the inverse sine of 1/4, you should get 14.5 degrees. Okay, plus 360k. All right. Now remember, that's only the first of 2 answers that are actually on our circle. The inverse function only gives us 1 of them, though. So what we did in the last section for problems like this is we drew 2 triangles. The one that we have, 14.5 in this case. And then the other triangle is going to be located in the other place where sine is positive. What other quadrant is sine positive at? Quadrant 2 is going to be my other triangle, which will also have a reference angle of 14.5. So now the other solution for theta is going to be that standard form angle, that rotation from the positive side of the x-axis that takes us to that hypotenuse on the second triangle. So what's the calculation I'm going to do to get that? To calculate that green line, I need to do 180 minus 14.5 to get that rotation there. And then that's going to give you the second answer. So 180 minus 14.5, 165.5. And if at this point you guys want to check it, you can do the sine of 165.5 and make sure it's approximately 0.25 because we rounded a little bit there. So you can just plug it back in and make sure that works, that you did that right. Okay, so those are the solutions for theta. Now let's put the 2x back in. So bless you. So 2x is equal to 14.5 plus 360k. And 2x is equal to 165.5 plus 360k. And then I've got to divide by 2. So 14.5 divided by 2, or times 1/2, gives me 7.25 plus 180k. And then if I do 165.5 divided by 2, I get 82.75 plus 180k. So those are all of the solutions that exist. Now we break it down into what of those solutions, which of those solutions are between 0 and 360. So first answer is going to be 7.25 degrees. And then we add 180 to that, so I get 187.25 degrees. And if I add 180 to that, I'm going to be over 360. So that's how I know to stop. The next answer is the 82.75. If I add 180 to that, I'm going to get 262.75. And then again, if I add 180 to that, I'm going to be over 360. Okay, so really similar to what we did before. You just got that extra little bit with the calculator you have to worry about to find those two answers on the unit circle if they're not given to you directly. So one of our exact values. Okay. Questions on that one? Moving on. All right, let's try this one. Find all solutions between 0 and 360 for 1 minus sine equals cosine 2 theta. 1 minus sine equals cosine 2 theta. Okay. All right, so we saw problems in the last section that had a sine and a cosine in them, but the cosine was squared in that one, and we replaced it with the Pythagorean identity. This one is not squared, it's a double angle. So what do you think we're going to do? We're going to use a double angle identity. Yes. Okay. This one I don't think is going to be on the test, the double angle. Anybody have their identity sheet? This one was the one that were 3. There were 3 identities. All right, so here are your options. 2 cosine squared minus 1, 1 minus 2 sine squared, and cosine squared minus sine squared. Yeah, the one that only has sines in it is going to be your best choice. Okay, and then again, this is still kind of back to what we were doing in the last section. Now I've got this kind of quadratic looking thing, so what should I probably do next? Get it equal to 0, and I like for that squared term to be positive, so I'm going to move everything over to the left. So that would give me a positive 2 sine squared, a negative sine, and actually if I subtract 1 on both sides, they just cancel. So it equals 0. How do I factor that? There's only 2 terms. This is the easiest form of factoring. Oh, you guys are like overthinking. What do they have in common? Let's take a sine out. 2 sine minus 1. And now you've got your factors. So just set them equal to 0. So sine theta equals 0. And 2 sine theta minus 1 equals 0. So for that one, if I get the sine alone, I'm going to get sine is equal to a half. All right, and we want answers in degrees, it said. Where does sine equal 0? 0 degrees. And 360, but remember, those are in the same location. So if you look back up in the instructions, it kind of tells you use 0 and not 360, equal at 0, not equal at 360. And then there's one other place where sine is 0, 180. And then 2 places where sine is equal to a half on your unit circle. Y coordinate equal to a half. 30 and 150. Is it easier in radians? I think it's easier in radians. I feel like we got to that point finally. All right, any questions on this one? 4 answers. Great. Okay. The next problem, I will give you these formulas on the test. So you will need the sum to product identities, which if you guys remember, those were the ones that were not as fun to memorize. So you will be given these 4, okay? Just have to know how to use them. All right, so we use it for problems like this. Sine 3x and sine 2x. Sine 2x, we could use a double angle identity, but sine 3x, we can't. And we don't want to do like proof type stuff where we have to expand it with other identities. So what we do is try to turn it into a product, because if it's a product and it's equal to 0, I can set all the pieces equal to 0. So we use sum to product. Now this one's a sine plus a sine. So using the third one down there, okay? So that's going to look like 2 sine, add up my angles, divide by 2. So 3x plus 2x over 2. And then cosine, subtract my angles, and divide by 2. And then we can simplify. 2 sine, I'll have 5x over 2. Cosine x over 2. And then that 2 out front, you can really just divide both sides by 2, which it'll get rid of it on this side. And on the other side, when I divide by 2, 0 divided by anything is still just 0. Okay, so I change it into a product. Two things that are multiplied together equal to 0, one or both of them equal 0. So now we split it into the two pieces. So either sine 5x over 2 equals 0, or cosine x over 2 equals 0. So each of those is like its own little mini problem now. I'm going to replace the angle with a theta for this first one. Can you solve for theta? Where does theta equal, sine theta equals 0? And we're back to radians here, between 0 and 2 pi. There should be two of them. 0 and pi, plus the period times k. So plus, what's the period of sine? 2 pi k, plus 2 pi k. Right? Once I have theta solved for, put the angle back in. 5x over 2 equals 0 plus 2 pi k. 5x over 2 equals pi plus 2 pi k. And then, how do I get rid of that 5 over 2 in front of my x? Yeah, use the reciprocal. Multiply by 2 over 5. Or you could do it in two separate steps. Multiply by 2 and then divide by 5, however you want to do it. So if I multiply everything by 2 over 5, I get 0. 2 pi times 2 over 5 is going to give me 4 pi over 5k. And then for the other one, I will have pi times 2 over 5, so 2 pi over 5, again, plus 4 pi over 5k. All right, and I'll come back and list all the answers out on that one in a minute. Let's go to the other one for cosine. Now, I already used a theta. Theta in this problem is equal to 5x over 2, so I'm going to pick a different Greek letter. I'm going to use alpha. It does look like a fish. All right, so where does cosine equal 0? Two places. Pi over 2 plus 2 pi k, and 3 pi over 2 plus 2 pi k. Oh, my computer's slowing down on me. All right, put the x over 2 back in. Pi over 2 plus 2 pi k. Ugh, it's glitching on me, guys. I might should go to the board and do this. And x over 2 equals 3. Come on, pi over 2 plus 2 pi k. Gosh. All right, how do I solve for x? Multiply by 2. So x equals pi plus 4 pi k. That's a k. Doesn't like my k's. And x equals 3 pi plus 4 pi k. There we go. All right, so I'm going to run to the board and list all these answers now. Okay, so these are all the answers that exist in the universe. So now let's start listing them out. From this first one in red, 0 plus 4 pi k. We want all answers between 0 and 2 pi. So my first answer is 0. My next answer is just keep adding 4/5, 5. 4 pi over 5. My next answer is 8 pi over 5. Do I have any more from that group? No, because I'm going to go over 2. 10/5 is 2. Okay, so next group, 2/5, 2 pi over 5. If I add 4/5 to that, I get 6 pi over 5. If I add 4/5 to that, I get 10/5, which is 2 pi, but we already had 0. Okay, so we don't need that one. Then pi. if I add 4 pi to that, I'm going to be too big. Even if I subtracted 4 pi, it's too small. 3 pi is already too big. And then if I add or subtract 4 pi to that, again, I won't get anything within that 0 to 2 pi range. So we have 6 answers. These problems, depending on what your original angles are, you can get a lot of solutions, like 10 or 12 solutions at the end. Now, really that last step is only going to be the part that is a little longer. Everything else will be the same. So you're going to do your sum to product, split it into 2 pieces, solve each piece individually, and then just depending on what numbers you have, you might have a few extra solutions because you're adding on a small fraction each time. Okay, so those are a big one on the test. You can imagine plus points. There will be one like this on the test. Yes, for sure. Just one. Well, some of them will have multiple solutions, but one that has this many solutions. Yeah, that's a lot. Okay, questions on that one? Do we want to practice another one of those, or we got it? Yes? No? We're okay? Okay, so I just have one more type of problem then. This will be the last one. It's this guy. Okay, so it's one that has an inverse in it. So when you have an inverse function, you are no longer solving for an angle. Okay, you're solving for a value on the unit circle instead. All right, so we're going to start the same way we did a lot of these other values before. Let's see if my computer has caught up on me. We're going to find out. I'm going to get that inverse tangent alone first. Okay, so first thing I have to do is subtract pi over 6. That's a little bit better. All right, so 2 inverse tangent x minus 1. And then I need to do pi over 2 minus pi over 6. What's my common denominator? 6. So it's 3 6, I can think about it as, minus 1 6, which is 2 6, or pi over 3. Then I'm going to divide by 2, or you can think about it as multiplying by a half. So inverse tangent of x minus 1 gives me pi over 6. Okay. I'm going to replace the x minus 1 with something easier. It's not an angle, so, I mean, you can call it whatever you want. I'm going to just put a y there for now. Okay. All right, so when we see a statement like this, inverse tangent of what gives me pi over 6, you can write it this way. You can think of it as tangent of pi over 6 is equal to y. That's an equivalent statement. Okay, we have the angle. We're looking for the value of the tangent when we see this. So can you tell me what the tangent of pi over 6 is? Tangent's y over x, right? What's the y coordinate at pi over 6? 1/2, and the x is rad 3 over 2. So it's going to end up being 2's cancel, rationalize. Y is equal to rad 3 over 3. If I solve for y, you can put the x back in. X minus 1 is equal to rad 3 over 3. And how do I solve for x then? Add 1. Rad 3 over 3 plus 1. If I write it with a common denominator, put them together, it's going to give me rad 3 plus 3 over 3, because I can think of that 1 as a 3 over 3. And then you can plug that back in if you want. Remember, a lot of these problems, you can take your answer, plug it back in, make sure it works. And that's it. That's it for 6-6. That's all problems we didn't get to yesterday. Okay. Any questions? No? Great. Okay, so homework deadlines. You guys have a Math Excel work day tomorrow for 6-6. If you had the circuit training from last week, if you didn't already, make sure you put it in the tray, and then I'll put the new one out for you here in a second. 6-6 Math Excel is due on Thursday, and then Thursday in class, we're going to do part 1 of the test review, which is already posted in Polaris if you want to get a head start on that. And then first part of the test is Friday. That's mostly going to be our law of sines, law of cosine stuff. We'll review again Monday, and then second part of the test, which will mostly be this equation stuff, will be Tuesday next week. I am making myself available before school both days of the test. So Friday before school starting at 7, and then Tuesday before school starting at 7, I will be here. So you can call it a study session or just come in and ask extra questions, whatever you want to do. I'll be around both of those days if you want to plan on it, if you feel like you need any extra view, especially because it's our last test. Okay? Good? All right, so the rest of the period is yours. I'll do cell phone lotto. You guys let me know if you need anything. Cell phone lotto winner is 12? 12. Somebody's in there.